This tutorial is to solve trig equations where we need a little bit of work beforehand. To solve equations we need to really get the trigonometric function sin x by itself first. So I'll move the 1 to the other side. 2 sin x equals -1, sin of x equals -1/2. Now I've rearranged the equation into the form that I want. I know it's a sine function, so I need to look at where will I find all stations to China. I need to find where will sine be negative, and sine will be negative in the third and the fourth quadrant. If theta is the answer in the first quadrant, then pi plus theta and 2 pi minus theta will be the answers in the third and the fourth quadrant. So x will equal pi plus theta and 2 pi minus theta, whatever theta is. To find out the value of theta, I go to the first quadrant and I'm looking for where will I find sine equaling 1/2. Here's my table, sine of 1/2, pi on 6 is the value of theta. Therefore x is going to equal pi plus pi on 6 and 2 pi minus pi on 6, where it equals 7 pi on 6 or 11 pi on 6. And there are two answers for x that make that statement correct with one revolution, that is that particular domain for x. The second example I have here is involving a cosine. Again, I need to rearrange. So root 2 cos of x will equal 1, cos of x will equal 1 on root 2. If I rationalise the denominator, I multiply it by root 2 on root 2, I get root 2 on 2 is the answer for the cosine of x. I'm looking for all of the answers within one revolution, so I need to consider all four quadrants, all stations to Coburg. X, I'm looking for where is the cosine positive. The cosine will be positive in the fourth and in the first. So the answers I'm looking for are theta and 2 pi minus theta. So x will equal theta, or 2 pi minus theta. To find out the value of theta, I need to visit the first quadrant, and where will I find cosine of x equaling root 2 on 2? Cosine root 2 on 2, x equals pi on 4. So x equals pi on 4, or 2 pi minus pi on 4, equals pi on 4, or 7 pi on 4. And they're my two answers for x.